Ladies and gentlemen, it is now time for the reason we are all here this evening. Today's session focuses on Introduction to Pre-Stressed Concrete Design, an essential topic in modern structural engineering that plays a major role in creating stronger, more efficient, and durable structures. It is my pleasure to introduce our keynote speaker for today, Dr. Pasindu Veerasinghe. Dr. Pasindu Veerasinghe is a graduate of the University of Moratuwa, where he obtained his bachelor's degree in 2015 with a first class honors. In the same year, he received prestigious awards including Most Outstanding Graduate of the Faculty of Engineering, Construction Engineering and Management Award, Building and Structural Engineering Award, and Hydraulic Engineering Award. He was also an active sportsman during his university years, receiving university colors for badminton consecutively from 2011 to 2014. From 2013 to 2014, he served as the captain of the University of Moratuwa badminton team. After completing his undergraduate studies, he obtained his master's degree from the University of Moratuwa in 2016 and later completed his Doctor of Philosophy in Structural Fire Engineering in 2020. Following his PhD, he joined the academic staff of the University of Moratuwa in 2021 and currently serves as a senior lecturer. In addition, he currently serves as the president of the Society of Fire Protection Engineers, Sri Lanka chapter, and as the senior treasurer of the Civil Engineering Society of University of Moratuwa. Without further delay, I would now like to hand over controls to Dr. Pasindu Veerasinghe to conduct today's session. Over to you, sir.
Right. Thank you very much, Yanga. So someone needs to give me permission to share the screen. So today it will be, pre-stressed concrete design is a vast area. We can't cover everything within just limited 2 hours, but I'll try to give you the basics of pre-stressed design and the design methodology in general, so that you have some understanding of what is the difference between normal reinforced concrete and pre-stressed concrete, and how you, the basics of designing a pre-stressed concrete beam. Right. And so whatever you think that is important to you, I suggest that you, make a note of it, because there's a limit that I can include in the slides, which I will discuss most of the time. And also, if you have any questions during the lecture time, feel free to ask them in the chat. And also you can unmute yourself and ask it yourself. I will be doing very simple calculations, just 2 calculations, not much. And I encourage you to do them with me, if you want to get hands-on experience on this. Well, let's see how it goes on, depending on the time allocation. Right. Now, basically, I will start from what is pre-stressing and how it differs from reinforced concrete, what are the similarities and differences of pre-stressed concrete in terms of the material behavior and how they're transmitting the load and the stress variation across the cross section. And pre-stressing have 2 main ways of applying the pre-stress: pre-tensioning and post-tensioning. So I will discuss about them, and different material and equipment that is needed for this production of pre-stress elements. And with time, the pre-stress that you applied will be lost due to short-term and long-term pre-stress losses. So we'll be briefly discuss on those aspects. And finally, the design methodology for a pre-stress concrete element. Right. So that is the basic outline for the today's workshop. Now, the pre-stressing is the act of applying a force. Normally, when we apply force to a structure, that force will actually cause the failure because structures fail due to applied loads. Now, the difference between a normal load and a pre-stressing load is the aim of applying this pre-stress force or this additional force is actually to enhance the structure's ability to carry the loads. So that is how the normal loads differ from pre-stressing loads. Before we go into the realm of concrete, let me just explain this using something that you already know, using certain examples from our day-to-day surroundings. Right, so if you take this wooden casket over here, I mean, normally we could have constructed this without these steel bands as well. But the purpose of having these steel bands around the casket is to apply a pre-stress. So if I explain it like this, the metal bands about around this casket is under tension. And you know that, I mean, according to Newton's third law, when you have a force, there's an equal and opposite reaction. So the equal and opposite reaction due to this tension in the metal bands is applied as a compressive force in these wooden staves. And normally what will happen is if you try to fill this wooden the casket with some liquid or solid, it will, try to expand, right? So in shell analysis, we call it as the hoop tension that occurs around this wooden casket. So, if the hoop tension is greater than the tensile capacity of timber, it will break. So the purpose of applying this pre-compression in the wooden stave is to reduce that overall tensile effect due to hoop tension, right? So in other words, we apply a tensile pre-stress on the metal band, equal and opposite reaction applied on the wooden as a compressive pre-stress, and that compression is trying to reduce the overall tension after you apply the load. So think of this wooden casket with and without these metal bands. If it is without the metal bands, what will happen is the stress will increase from 0 to tension. If you say negative, tension is negative, it will start from 0 and increase in the negative direction. But now since we have initially this compressive pre-stress, it is in a positive stress state. And the negative tension due to the hoop tension, the liquid pressure will start from a positive value. So positive value gradually will become 0 and turn into negative. But the overall negative effect of the overall tension is less than before. So the act of applying a pre-stress on these metal bands, what it has done, it has actually enhanced the capacity of the wooden casket in terms of resisting the hoop tension, right? So if you take another simple example that you already experience every day, now all of our vehicles have a pneumatic tire on it, right? And the pneumatic tire is inflated with air. And due to the air pressure inside the tire, air is under compression, but due to that compressive air pressure, the side walls of the tire is under tension, right? These are stretched because of the air pressure inside. Now, what will happen when you try to load, or when the load is applied on these tires, what will happen is this initial tension due to the air pressure will reduce due to the compressive weight of the car. And ultimately, what you will have is a lesser amount of tension in the tires. Due to the air pressure, there was a tension. When you load it, a compressive stress is applied, and compression and tension balances out, and some tension is left on the tire. Now imagine this tire without air, what will happen? initial tension will not be there. So what we will have is only the compression. So tire will be purely under compression. Now, because of this initial pre-tension, what has happened is now initial tension has reduced a little bit due to the compression, right? So it has actually reduced the overall compressive stress that can be applied on the tire because of this initial air pressure inside the tire. Again, an example of how a load that is applied on the structure enhances its load carrying capacity. So now the wheel can carry more compression because initially it started from a tension. If it started from zero stretch rate, it will be purely in compression. Another example, the bicycle wheel. And the bicycle wheel, the load from the bicycle is applied on the center part, and it is connected to this wheel using these spokes. And you can see the spokes are very, thin sections. And normally, if you just apply a load here, what will happen? So you apply a compressive load here, and the gravity is acting on this particular point. So you have one load coming this way and the other load going up. So the spokes will be in compression. And you know that compressive elements are subjected to buckling. And if this is a very slender element, so it is susceptible to buckling if this is slender like this. So we would need very, what you call, thick elements to connect the center part to the wheel. And obviously the weight of the wheel will increase. But instead of that, initially these spokes are subjected to tension, right? They are stretched and the nipples are locked in the wheel and the wheelbase. And then what will happen when you're riding the bicycle, or when you fix this wheel into the bicycle, the load of the bicycle will be acting downwards from this location. And the reaction that is coming from the ground will be opposite like this. So due to these forces, there will be compression on this side and tension on the other side. So eventually what will happen is, because it is initially in tension on top and bottom side, the top part tension will increase, and bottom part, what will happen? This initial tension will reduce due to this compression. So we have a reduced tension. No, it will be slightly in compression, but not significant compression. So because of this pre-stress, you could have used very thin element like a spoke wire, which cannot carry any compression. It can only carry tension. So even though you apply a compressive force due to the weight, finally it is under tension, both the top part and the bottom part. So the wheel is in full tension, and that happened because of this pre-tensioning force in the spokes. So if we apply the same concept for concrete, right? In this bicycle wheel, the spokes, they couldn't carry the compression. So the deficiency in the bicycle wheel was lack of compressive strength. Similarly, we have a deficiency in concrete, that is a lack of tensile strength. So then what can we provide is what is lacking. I'm sorry, the opposite of the deficiency. So the bicycle spoke, it can provide the tensile strength. Whereas concrete, it lacks in tension. However, it is performing well in compression. So it has good compressive strength. It's the opposite of the deficiency. Then what we should do is, we should make sure ultimately when you apply load, in terms of the bicycle wheel, the spoke should be in tension because it is good in tension. Whereas in terms of concrete, it should be in compression because it is good in compression. So in order to do that, we should apply a pre-stress force. And in terms of the bicycle wheel, what we do is we pre-tension the spokes and fix it in the wheel and the wheel base through nipples. And in concrete, through a pre-stressing jack, we apply a force on a tendon. The tensile force is applied on the tendon and the equal and opposite force, the compressive force, is acting on the concrete member. I will explain that further in the next few slides. And once we apply this pre-tension, or whatever the pre-force, there should be a way to lock this. Otherwise, what will happen is if you release the force, it will, if you stretch the spoke wire and just release it, there will not be any pre-stress lock there. So we should lock the force. Then only this pre-stress will remain in that particular element. So in terms of locking, for the bicycle wheel, we are using the friction, or the spoke is connected from the nipple and the rim. So the friction between the nipple and the rim holds that or locks that force together. Whereas in concrete, it could be either the anchorage of the tendons. Anchorage means if it is a post tension member, we anchor from two ends so that the force is locked, or else it can be the bond between the tendon and the concrete once you release the stress. So I will explain that in more detail, but try to get the idea. So something is lacking in concrete, so we have to make sure it is in compression. In order to make it fully compressive, the cross section in compressive stress, we apply something called a pre-stress. And in both cases, significant amount of energy is stored in the system. And let's say if suddenly your spoke wire breaks, what happens is suddenly detach and release a significant amount of energy. The same thing can happen in pre-stress members. If by any chance the anchorage blocks fail or the bond between the pre-stress member fails, a sudden energy release can happen. Sometimes it is a disadvantage of pre-stress members, but given the conditions, it rarely happens, right? So if you look at the difference between now reinforced concrete versus pre-stressed concrete, I hope every one of you is aware of the reinforced concrete. Now in reinforced concrete, you apply just the normal um, reinforcement at the tension zone. Let's take a very simple case, simply supported beam, and the reinforcement is going below the neutral axis like this. And when you apply the load, what will happen is it will deflect downwards. And when this is deflecting downwards, you can see the bottom part is subjected to tension, whereas top part is in compression. So concrete is good in compression, so it can resist the compression, whereas bottom tension, it cannot resist very well. So therefore it will crack. And the reinforcement is taking all the tensile force. So in a reinforced concrete section, it is anyway a cracked section, because even under the working loads, the bottom part will be in tension. We can't see the cracks, the micro cracks, but if they are greater than 0.3, it can be considered as a failed section. However, the point is, in a normal reinforced concrete member, it is, if you take a cross section, it is subjected to both compression and tension. Whereas a pre-stressed concrete member, so instead of just inserting the steel, we insert the steel and lock it from two ends. So that means we are applying a tension on the wire. So whereas the equal and opposite force, the compressive force, is applied on the concrete member. So due to this initial compression at the bottom part below the neutral axis, you can see before applying the load, this will be deflected upward. So that deflection due to this pre-compression is called the upward camber. Slight deflection upwards. And once you are applying the load, what will happen is this slight deflection upwards will either be zero or deflect downwards. However, you can see compared to these two, now this is deflecting from a zero position to a negative, or let's say positive downward direction. But here it starts from a negative deflection, upward camber. Then it's deflecting downward. So one thing is the deflection of pre-stressed concrete members is comparatively less than reinforced concrete members. And the other important thing is, although this is having a tensile region, pre-stressed concrete members, we can make sure that if you want really, we can totally avoid the tension, right? So if we illustrate that further, in a reinforced concrete member, above the neutral, if it is bending downwards, let's say the neutral axis passes through the centroid like this, if it is a rectangular section, above the neutral axis, this part, the material is trying to squeeze in, therefore it is compression, and below it is trying to stretch, material is under tension, so you will have a triangular stress distribution. One part is in compression and the other part is in tension. So this is the strain distribution, and at failure, we idealize this to be a rectangular stress block. And one part is in compression, it is carried by concrete. The other part that is in tension carried by the reinforcement. And I mean, the cross section is in both compression and tension. Now in pre-stressed concrete members, it is different. Before applying a load, you are applying a pre-stress, right? Due to the pre-stress, what will happen is pre-stress is applied below the neutral axis or at a certain distance below the neutral axis with a eccentricity of E. When you apply the pre-stress like that, two things will happen. So concentrate on these two diagrams. Now, because this is going through the axis of the beam, it will create axial compression, first of all. So that is represented by this one. Force divided by the cross-sectional area, that is the axial stress due to the pre-stress force. And due to this force, what will happen? It will deflect upwards, or the upward camber will happen, will deflect like this. And because of that, you can see that now the top part is in tension and bottom part is in compression. So this is the stress distribution due to the upward camber. If you take tension as negative, so the more, I mean, if you know the most important formula that you will ever remember, MOI equals sigma over y, right? And this then sigma, I can write it as M divided by, sorry, I over y. And this I over y is called as the section modulus, or Z. So basically stress is movement divided by the section modulus. And here, I mean, the moment that is generated due to the pre-stress is moment force multiplied by the distance from the centroidal axis, P times E, divided by the section modulus. So here we have two terms, ZT and ZB. The reason being, I will explain it later as well. Now, if the centroidal axis is not right at the center, I will take example like a T section. Yeah, let's say the centroidal axis is somewhere here. So then the Y distance, the distance from the neutral axis for the extreme fiber is different in the top direction to the Y, the distance from the neutral axis to the bottom part. So when Y changes, you can see even though you have the same I value, when Y changes, the section modulus changes. So that is why we have a different notation for ZT and ZP. Right. So then when this is deflecting upwards, you will have tension at the top part, compression at the bottom part. And that particular tension is moment divided by the section modulus, moment due to the pre-stress, P times E. So these two stress diagrams are corresponding to the pre-stress force that you apply. And then when finally, when you load this one, so when you load this, what will happen? This will now deflect downwards because of this distributed load. And because of that, bottom part will be in tension, top part will be in compression. The stress distribution like this, similar to this one. And now the M is the moment due to the applied load divided by the section modulus at top and bottom. So if you consider tension to be negative, it is negative at the bottom part. Now the resultant stress distribution across the cross section is the summation of these three components. The axial stress due to pre-stress, the flexural stress due to the upward deflection or upward camber, and the stress distribution due to the downward flexure due to the downward applied load. So you can see, I mean, if it is not for the pre-stress, you would have only this one. Now with the pre-stress, you have another two components as well. So we have, if you take the resultant here, compression, a small tension and a higher compression. So this will be in compression, definitely. Bottom part, this is again a compression, a small compression and a larger tension, because the moment due to the applied load may be greater than the moment due to the pre-stress, right? Then, I mean, here you have it can be in compression as well, or else if this tension is greater than these two compression, it can be slightly in tension. But the point is, now the whole cross section is in compression. So compare this to this one. Now in pre-stress members, we can make sure even after we apply the loading, the cross-sectional stress is in compression. So that is the trick in pre-stress concrete. And concrete is good in carrying compression, but in order to come to this point, it has to carry some tension initially as well, but which is a very small amount. But ultimately, when you load it at the working loads, it will be in compression. So this is the game changer that gives the ulterior properties for the pre-stress members. So try to understand this stress contribution, because this is the basis for all the design equations that are governing the pre-stress concrete design. The stress variation of a pre-stress member at, I mean, when you apply the pre-stress and also when you load it, right? Okay. Right. Then if you look at the differences between the reinforced and pre-stress, looking at all the stress contribution as well. Now in reinforced concrete, part is tension and part is compression, whereas pre-stressed concrete, the whole concrete cross section resists the external loads, and that is in compression. Whereas this is only part resists the compression, other part is carried by the steel. And reinforced concrete may develop micro cracks because of the tension zone of the concrete, whereas pre-stressed concrete, there is no tension or little tension, thus eliminates these cracking due to the flexure. If for reinforced concrete, we don't require, I mean, high strength concrete is there, but we don't specifically require them. The normal low strength concrete and steel is sufficient. But for pre-stressed concrete, you can see, I mean, to apply the pre-stress, we need a higher tensile strength in steel. And to resist this additional pre-stress, compressive stress due to pre-stressing, we need higher concrete strength as well. And it is sensitive to the time. So we have two stages at transfer and at service. So when you are looking at that, discussing that point, I will emphasize why we need high strength concrete for pre-stress concrete. So right, there's a question all the time to pre-tension compression. If yes, tendons need to provide more the required. I mean, question is not that clear. Can you rephrase it and ask it again, please, so that I will give you answer. Right. Um, So reinforced concrete does not require any special equipment because I mean we don't have to any apply any pre-stress or anything. But pre-stress concrete requires tensioning equipment, anchoring devices, locking devices, and form work, special form work as well. So a lot of I mean work should go on before you do the concreting. And for reinforced concrete to control the deflection, we may need very deep sections. Whereas now pre-stressed concrete, anyway the deflection is limited due to the pre-stress, so we can reduce the section size, and reducing the section size will give you light sections. So that is why you see, I mean, when the span increases, when always it is better to go for pre-stressed concrete. So in bridges we go for pre-stressed girders, whereas if you are using reinforced beams, and the beam size of I mean the bridge beam will itself will be very high, and the self weight will, to carry the self weight, it will need more reinforcement. It's like a vicious cycle that goes on. So for reinforced concrete, only ordinary supervision is enough, whereas pre-stressed concrete, we need to maintain quality supervision. We need to apply the correct pre-stress. We need to make sure that the concrete is having the highest strength, and a lot of monitoring should be going on. All right. Before we go to the next session, if there are any questions. Can we design pre-test being partially in tension? Yes, possible. I mean, uh, now in pre-stressed concrete design, we have normally three stages. That is the transfer stage where you apply the pre-stress, then the service condition where it is subjected to working loads, and the ultimate limit state. So at the ultimate limit state, anyway, the pre-stress beam will be subjected to tension. So the tendons that to insert, I mean, at the ultimate limit state, eventually they will have to carry some tension as well. But in the working condition, you can make sure that it is subjected to purely compression if you want. In that case, also some tension can be there. Then if there is tension, you have to provide reinforcing steel apart from the pre-stressing tendons to carry that tension. But the tensile force in the pre-stressed member is less than a similar reinforced concrete member. Right. So now pre-stressed concrete, as I mentioned, it has mainly two ways of applying this pre-stress force. One is using these end abutments. We can fix a steel wire or a tendon and then jack it from one end and apply this pre-stress force to this tendon. So eventually this tendon will be in compression, and then what we can do is we can put the concrete or pour the concrete while this is in tension. And once the concrete is hardened, you can release the tension by cutting off this tendon. Then when you cut this off, what will happen? Initially the pre-stressing strand is in stretched tension, so it will try to come back to the original position. And in doing so, it will apply a compressive force in this one, so it will be deflected upward. So this is the transferring phase of the pre-stress. We call it as a transfer stage, basically the manufacturing stage. So this is called pre-tensioning. And the other way of applying this force is post-tensioning. Post-tensioning means after you do the concrete. So when you're doing the concreting, you leave aside the duct like this, a free space where you can insert the tendon later. And then a wire is inserted or the tendon inserted and anchored from one end. And then you fix the jack from the other end and pull it. So what will happen? We apply a tension for the cable, and because of these two ends, it will try to apply a compression on the concrete. And then when you jack it and lock the force using another anchor, this compressive force on the concrete member is locked. So this is the post-tensioning method. So pre-tensioning, I have explained all of this. Ideally, this is suitable for a factory condition because you can, not only this member, you can have the strand very long and have multiple members within the strand. And once you do the concrete, you can cut everything. So within 1-2 anchor blocks, you can have multiple elements. And this, since we can, this is more suitable for a off-site or a factory construction. And tendon profiles which are not straight is also possible, because if you have hold downs and support like this and jack it, then even if you stretch it, the tendon will have a parabolic shape. Right? And for the pre-tension members, usually the size is small because we have to transport these members from the factory to the construction site. So railway sleepers, which are a repetitive one, the light poles, and certain bridge girders as well. They were manufactured maybe not on the site, on the site itself, maybe not on the bridge, but at the ground level and then hoisted up. So whatever the method that you transport, if you apply the force before the concreting, it is called the pre-tension. And the next one is the post-tensioning. So I explained this one before, how you apply the post-tension. So after you apply the post-tension, either you can fill this duct with a grout. So if it is filled with grout, we call it as bonded post-tension beams. And also you can keep it unbonded without filling it, just anchoring from these two locations. So such ones are called unbonded post-tension beams. So post-tension members, the post-tensioning need not to be always applied inside the element. So they can be applied externally as well. So these are the anchor blocks and the cable is stretched between these blocks and locked. So eventually this will apply pre-compression. And you may have seen this in like box girder type bridges, the cables coming out, and this is the anchor block. After you jack it, you have anchored that. And why we use post tensioning is predominantly because, certain, let's say a box girder like this, one thing is it is curved shape. And the other thing is, if you are going to transport this from a factory to the site itself, it's a very large element. So you can't do it easily, difficult. So the best way is to cast the concrete on the place itself, insert the tendon later, and apply the pre-stress after concreting. So that is why the post-tensioning members are mainly large members. And not only girders, you can post-tension the bridge decks, and also these post-tension slabs post-tension flat slabs are now becoming popular because it eliminates the need of beams, and you can go for a larger span between the columns. So one thing is it reduces the cost for the formwork, and you can have more space between two columns, aesthetically better, rentable space is higher. And also, the floor to floor height can be reduced because there is no beam. So how you get the strength, the additional stiffness that is not given by the beam is through this post-tension steel. Now the difference between the pre-tensioning and post-tensioning. So pre-tensioning tendons can be straight or either curved. Post-tensioning, it also the tendon can be curved, or it even can have a curvature in the horizontal plane. Whatever the position that you place the duct, it can take the tendon profile. These are pre-tension members usually produced in precast yard, but post-tensioning it can be done on the site. Size of the member is limited for pre-tensioning because you have to transport them, but post-tensioning there is no limit in the size because you can do it in situ. Pre-tensioning, it is anyway bonded because to transfer the pre-stress it should be bonded. Uh, but post tensioning, it is unbonded. If it is unbonded, there is some risk of, sorry, this should be steel. Risk of steel corrosion is high. So in such cases, if you do post tensioning, where there is high risk of corrosion, we have to fill it with grout lead. I will explain how we can do that. Pre-tensioning tendons are bonded, so therefore you can't remove it. Whereas post-tension unbonded ones, you can remove it later and stressed. So this can happen in bridge beams, bridge girders normally. With time, what will happen is the pre-stress force that we apply can be lost due to pre-stress losses, which I will discuss later. In that case, what you can do is you can again re-stress them if they are unbonded. If they are pre-tension members, you can't do that. Post-tension members, you can remove this anchor and remove the cable and do the pre-stressing again. Pre-tensioning loss of pre-stress is high because it is, bonded throughout the length of the cable, whereas post-tensioning loss of pre-stress is comparatively less because it is connected only at two ends. If the anchor blocks are stiff, the loss of pre-stress is comparatively less, but still there's a loss of pre-stress. So these are the particular equipment that we use. Unlike reinforcement, the diameter of these pre-stressing tendons are less, 3 to 7 millimeters, and by spinning several wires around the central core, we generate what we'll call a strand. So these are strands. And the pre-stressing force is applied using a jack like this. This is like a pre-tension jack, and this can be a post-tension jack. So when the cable is coming out, it can be fixed to the cable like this and jacked from this position. And these are the anchor blocks. So although you can see this part outside, inside you have the duct and also a grouting hose. If you want to insert the grouting after anchoring, you can insert it from this part. So this inside the duct will be filled with grout, and then you can seal this. Right, this is the one without a duct anchor block. And right, before we go to pre-stress losses, are there any questions from the things that we discussed so far? So I need a moment break as well, speaking for almost more than 1 hour. Right. Any questions so far? Right. Okay.
Hello, sir.
Yeah.
Okay. Relatively, is a free tension is a forced tension. Is a based on the is a length depend is a which one is a we use it is. Is am I right? Because it's
Uh,
a, which one is a mean is a cost effective. Which one is a suitable mean is a forced tension is a mean is a span length and the free
yeah,
tension
if
span
the
length.
span is larger, we have to go for a large elements. Then, transporting these large elements, pre-tension may not be possible, so we may have to go for post-tensioning. And maybe another reason means if you have like curved elements, difficult to apply this curvature in the pre-tensioning. So that way we can leave a duct and do the post-tensioning later. And if you take element like slab, now slab is a plan element. You can't, you can do it, but impractical to transport a pre-tension slab and fix it there. So the best thing is to do the post tensioning. In terms of girders, it depends on the size of the member that you require, and also some practical considerations like, if the pre-stressing yard is very far away, transport it rather than spending cost on transportation, you can do the post-tensioning on the site itself. And a lot of the segmental box girder type ones are post-tension, because you insert segment by segment leaving ducts, and the strands that you insert actually helps to hold these segments together. And once you apply the post-tensioning, it actually sort of place these and hold these in one position and acting like the bond between different segments as well. So that is another benefit of why we are using like this one, the post-tension segmental box girder type bridges. Now, if you look at the new Kalani bridge, it is something like this. If you go for a higher span, you need a very deep section like this. Yeah, thank you for that
Thank you.
question. Yeah, any
Thanks.
other? Good that you ask these questions, because others can learn as well from the thing that you question.
Dear
And
sir,
yeah,
during the post-tension prestressed concrete, when we grout when we insert the duct, after we keep this duct permanently, or we remove the.
duct, we have to keep it permanently. We are not using any expensive material for the duct. It is like the conduit pipes that you insert in the slab to put the electric cable, something like that. But better performance than that. Because usually I mean, it's not that, even if it is expensive, you can't take it out once the concrete is hard. So duct, we are not taking it anyway. But if the strand is losing the pre-stress, we can remove the strand and insert it later and jack it after that. That is possible.
Thank you, sir.
Okay, so let's go to the next session. Right. Now, the magnitude of this pre-stress that to apply for concrete member undergoes changes during the lifetime of the member. So initially you may apply a pre-stress of P node, but with time it is reduced due to the elastic deformation and slipping or degradation, things like that. So that initial loss from the initial jacking force to the transfer force is called as the short-term pre-stress losses. And in the long term, due to the creep, shrinkage or stress relaxation of steel, further loss can happen. So eventually, at the full load or at the working condition, you will have an effective pre-stress force of PE, which is anyway less than P naught, and even the initial force at the construction stage is less than the initial jacking force. So in design, actually, we should estimate these things. So just to illustrate, so let's say you apply a force of this 10,000 kilonewtons for all the pre-stressing tendons. So then due to the friction, elastic shortening, the short-term losses, it will lose some portion. And due to the creep, shrinkage and relaxation, it will lose more. And finally, effectively, we'll have about 7,500, effectively about 28% of force is lost due to these losses. Right. So then I will briefly go through the design methodology. First, I will explain, and there are simple examples. I will try to show you the methodology. I hope that you can do the calculations yourself. Anyway, it's not the time to do all the calculation, but I will show you how to do them. So first, we calculate the initial moments due to the loading that could occur, and we should find what are the stress limits that we can apply for this particular member in the transfer and the final stages. I will explain them later. And in order to resist the stress limit, we have to select a particular trial section, and we can check whether this section is adequate or not. I will show you how. Then we draw something called a Magnell diagram to find out what is the effective P and E that you can apply. And then we look at, what is the tendon profile, how much below the neutral axis that we should apply this pre-stress, and whether we need this, whether we can have a straight tendon or a curved one. And we can calculate the pre-stress losses and deflection. Now, unlike reinforced concrete, you can't define a span or effective depth ratio because there will be initial upward camber due to the pre-stress, so the deflection will depend on the pre-stress force as well. So we have to actually calculate it and show that is within the limits. And finally, we can check for the ultimate limit stress. So all those checks up to the deflection, including the Magnell diagram, pre-stress losses, and tendon profile or trial section, all these are serviceability checks that we do. So we design the beam in the serviceability stage and come up with all these parameters. And finally, we check it for the ultimate limit state moment and the shear as well. So to understand the methodology, we will again need these previously discussed parts. That is, due to the pre-stress force, there will be initial compression and the upward camber. So this is the stress due to the pre-stress. And due to the loading, there will be downward tension and upward compression flexural stress behavior. So finally, the behavior is like this. So after applying the working loads, the top part will be significantly in compression, bottom part will be in slightly compression, or it can be up to the tensile side as well. So then if this is not to fail, what should happen is this top stress or the max compressive stress that is due to the loading and the pre-stress should be less than the maximum stress of concrete. So if you take compression as positive, tension as negative, so P over A minus flexural stress due to the pre-compression, P over ZT, plus the moment is considered as a maximum moment in this case because it is under the working conditions, divided by this ZT. So whatever this top part, addition should be less than the maximum value. And if you look at the bottom part, SP, this P over A plus PE over ZB, because this is compression, minus Mmax over ZB, the tension due to the applied loading, you get a stress less than this one. So we should check, now this is the minimum compressive stress or the tension that you are getting. So you should check with the minimum stress of concrete. So this bottom value should be greater than whatever the lower limit of stress in concrete. So this F min can be a tensile stress. Why we use the serviceability limit state, not the ultimate limit state? That. Right. So we are basing our design based on the stress condition at the serviceability limit state. So at the serviceability limit state, we should make sure that, it is not subjected to cracking and the material, should withstand this applied loading. And anyway, we are checking for the ultimate limit state as well. It is not like that we design for the serviceability limit state and stop it there. We do the check and make sure that the ultimate moments can be also resisted by this pre-compression. And if that is not the case, we have to provide additional reinforcement to resist that. So this is to determine what is the pre-stress needed what is the cross-sectional size needed, and how many tendons that you have to apply. That sort of information can be obtained from this design, right? And before loading, what could happen is, so this is after loading. Before loading means now, before you apply this external load, it will have only this pre-stress and the self weight of the beam. So due to that, what will happen is the opposite of this one, right? Instead of, now these two will be anyway there. Instead of this one, again the self weight is downward, so we will have a stress variation like this. But now the tension here is less. Compression here is also less. So if you look at the top part, it has two compressive stresses, low values, and a higher tension. So the stress at the top part will be something like this, low in compression. If you look at the bottom one, you have two compressive stresses and a very low tension. So bottom part will be subjected to compression like this at the initial stage. So this is SB and this is ST at trans, right, at this stage. So then this lower stress value should be greater than the same notation. I mean, P over P over ZT does not change. Again, M over ZT also it is compression, but now here minimum moment, that is minimum moment is now the moment only due to the self weight over ZT should be greater than the minimum strength of form. And the bottom part where you have the compression greater than the top one. The addition P over A, PEO is at B minus minimum moment over section modulus at the bottom should be less than the maximum stress at that particular point. Maximum stress of concrete. Now in both loading and transfer, I have considered the same notation Fmin and Fmax. But in the actual condition, it is not the same because loading, you will do it maybe after 28 days, but the transfer of stressors will happen right after the concrete hardens. So you will cut the wire at about, let's say, within 7 days or within first week. So this should be Fmin and Fmax at that particular stage of concrete. You know that concrete has a strength development all the time. So we have to consider the maximum and minimum concrete stressors at 7 days or 3 days or 5 days, whichever you make the transfer. And here at the time of loading, we can consider the characteristic strength of concrete after 28 days. So then you will have two different notations for this Fmin and Fmax T. Right? Then if I take these inequalities, delete this. And slightly rearrange them, right? I will take all the moment values and take P values here and then arrange it in a different way. And the same expression, arrange it like this. We will arrange it this way. Similarly, the bottom stress, this inequality, I can arrange it like that. So 1 over P as the dependable variable and E, the eccentricity, as the independent variable. And these are now, if you choose a particular section modulus and the area is same, so the constant moment value will be, the moment at that particular location, and maximum and minimum stresses are properties of the concrete. So what you can play around is where you apply the pre-stress force E and what is the pre-stress force, the magnitude of P. So this will be Y and this will be your X value. Similarly, I can change these two inequalities as well. So, and I can arrange it like this. So now I have two inequalities at transfer considering the stress at the top and the bottom part. two inequalities after loading considering the stress at the top and bottom part. And you have different size, one OP is less than, greater than, less than. So if I plot these curves in a Cartesian plane, because area, section modulus, the stress of concrete and moment are fixed values, you can see 1 over P is proportional to E. So if you plot a chart between 1 over P as the independent variable, E as the independent variable, 1 over P as the dependable variable, then you will get, because of D and B, you will get these two lines. So you can see when 1 over P is equal to 0, when I equate this, let's say take this expression, 1 over P is equal to 0, this part will become 0 and E will be equal to minus ZB over A. So this will be starting from this one, on a straight line like this. Then 1 over P making 0, from D also you can get E eccentricity is minus ZB over A. So these two lines will be starting from B and D will be starting from position like this. And 1 OP, one case it is greater than this one, and the other case it is less than. So it is in between, the acceptable zone is in between these two lines. And if you plot A and C, if you equate 1 OP into 0, you'll get E is equal to ZT over A. And here also 1 OP makes it to 0, E will be ZT over 0. This is where 1 OP is 0, the x-axis. So these A and C lines will start from there, and one is greater than, one is less than. So the region is in between these two lines. So the region that satisfies all these four inequalities is in between these two lines as well as in between these two lines, right? So then the common region that is acceptable or satisfying all these four inequalities is this shaded area. So these two inequalities could have been solved algebraically as well, but rather than that, graphically solving this is much easier. You can visualize it very nicely and visualize the region of interest as well. And this is called the Magnell diagram, right? So through a Magnell diagram, what we are doing is we are actually solving these four stress states at transfer and after loading. So the aim of constructing this Magnell diagram is why? From this one, within this acceptable zone, you can select an appropriate 1 over P value. So if you know 1 over P, you can select the P, the pre-stress force. And if you know the eccentricity value, you can know where you can apply the pre-stress force, E value. Right. Now I will take the same stress conditions. I will make a slight difference here. The only difference that I'm going to make here is, now instead of making FA min, FA max same in both four equations, I will say FA min at transfer, FA max at transfer, the maximum stress of concrete at transfer, minimum stress of concrete at transfer. That is one modification that I have done. The other modification is here you have in all four inequalities, you have the same P, but that is not the case because due to the pre-stress losses, the force during the transfer stage and force after the loading will be different from the jacking force. So if you take the initial jacking force as J, so if you take the nominal values, about 10% loss can happen at the transfer. So at transfer, the force PI will be 0.9 times the jacking force. And further 15% reduction can be anticipated at the service stage after loading. So this will be only 75% of the jacking force. So therefore, if you take the PE over PI ratio alpha, it is about 0.83. This this 0.75 divided by 0.9. So therefore, if I denote this as Pi, PE can be written as alpha times Pi. So if you know alpha or the percentage of pre-stress losses, we know this alpha ratio. So the force in this second set of inequalities can be expressed in terms of Pi. So here I use Pi, and here instead of PE, the load during the service is denoted as alpha times Pi. Then if I apply, if I take this C and multiply A by alpha, what will happen is this Pi terms, because this is alpha Pi over A, alpha Pi over ZT, and this is just without alpha. So if I multiply this by alpha and reduce this, these two terms will cancel out and you will be left with only these two. So it is the expression there. And if you rearrange this a little bit more, I can get the expression for the section modulus at the top part is therefore ms minus alpha times m naught, where ms is the moment at the serviceability condition after loading, m naught is the minimum moment when you have only the self weight. And here the inequality change, I mean same thing can happen in equation D and B as well, and the initial two terms will cancel out when you multiply P by alpha. And if you rearrange this a little bit, you will get an expression for ZB, right? So this tells us, I mean, without finding the P or E, if we know the moment that could be expected during the initial stage and at the service, and if you know the material properties, the concrete stress conditions at initially and at the transfer, you can select the section modulus that will satisfy these inequalities. So that means we can, without knowing the pre-stress at this stage, we can trial out a section, right? We can assume a certain section and we can see, and when you assume a certain section, you know m naught value, and the loading is anyway based on the arrangement of the structure. So you can find ms as well. The material properties at each stage can be known if you know the strength of concrete. So you can determine a suitable section for your pre-stress member. So this is called the inequalities that gives us the initial sizing of the member. The first few steps in our design. And so to understand this, to solve these inequalities, apart from the moments, what we need is what is this FA max, FA min, or FA max T and FA min. So at transfer and at service, what are the stress values that you can consider for the concrete? So normally in concrete, what we need know is the characteristic compressive strength at that particular age. So for the concrete code or the Euro code that governs pre-stress design, what it tells is at transfer, the FA max, the maximum stress that the concrete can take may be limited to 0.6 times FCK, the characteristic compressive strength of concrete, 60% of that, because we are doing the design at the serviceability limit state. However, now FCK should be the compressive strength at the time of transfer. That means if it is transfer is happening at T day, 3 days, FCK should be the 3-day strength of concrete. So out of that, you can take 60% as the maximum. At the service, that is after you apply the load, after you place this beam on the structure and apply the load, again the stress is limited to 0.6 times FCK, but now FCK is the 28 days compressive strength. Right? There's a difference between FCK at trans and FCK at service. And there's a case called the quasi-permanent case. I mean, quasi means the, so the spellings is again different. QUASI. Okay. QUASI quasi-permanent means the loads are permanent. Just like when you place a beam, apply the finishing screed, and before you apply the full load. In that case, if you are considering the stress conditions, you can use a maximum compressive strength of 45% of the characteristic strength, right? A little bit less than this one. And in tension, now previously in British code, it was a little bit complex because you can classify the section according to different classes, and if it is class 1, no tension can be applied. If it is class 2, some tension can be applied, blah blah. It has different rules, but now the Eurocode, it has simplified. Simply the tensile stress that you should apply is the medium tensile strength or the characteristic median tensile strength using the appropriate FCK value. If it is at transfer, FCK at transfer, the corresponding FCTA. And where you can find these FCTM values is in the Eurocode. Right. In Eurocode, there is table 3.1 which specifies all these material properties. And yeah, this one. So table 3.1. If you know the characteristic compression, whether it is 20 days or 3 days or 7 days, you can find the corresponding FCTM value. So it is about roughly 10% of your characteristic strength, but there's an equation given as well for different characteristic strength. You can find the corresponding tensile strength of concrete. So however, this value should be a negative value because in pre-stressed concrete, we consider tension to be negative. If you are using Eurocode, yes, the limits are different, but don't do the design for both Eurocode and British code. If you're following the Eurocode, follow the Eurocode and do the design. According to Eurocode, actually now we can apply certain tension because it is up to the designer if you are limiting the tension to 0. But in British code, different classes are there. Class 1 means you don't apply tension at all. So the tensile capacity should be taken as 0 in that inequality. That is the only difference. Don't mix the two codes. Do it for, do for the Euro code, and that is anyway the one that is being practiced. No? The British code. I just wanted to show you how it changed from the Euro code to the British code. That's it. Right. I don't think, given the remaining slides and the time limitation, we have enough time to do these examples. Anyway, I will share the solutions for these examples so that you can understand with the slides that I shared today. So I will share those later. And Now again, after you select a suitable section, you can draw the magnal. Right. So after you select the initial sizing from these two inequalities, you can see my screen, right? No.
Now we can see that.
Right. Okay. Fine. So after you decide these initial section sizes, then you can construct the magnal diagram. For the magnal diagram, because you need ZT and Z. I mean, without this one, you can derive the inequalities. So that is why we determine first whether ZT and ZB is adequate or not. Once you do that, I mean, you can generate these four inequalities and draw them in a graph and find these four lines and select the region that is acceptable within these zones. And in certain cases, there will be additional constraint because the maximum eccentricity that you can have is, let's say you have a beam like this and the centroidal axis is like that. So the maximum eccentricity is only up to the edge of the beam. So there's a limit for this eccentricity value that we can have for the pre-stress. So that will be this value, Emax. So your actual acceptable zone is then limited to this particular region. So you have to pick one value and select an appropriate E value and appropriate 1 over P value. That is the second stage of the design. And thirdly, once you selected the p-value, now again the same for inequalities at transfer and after loading, I can rearrange them where now E is the dependable variable. So this inequality I can rearrange where E is less than a certain value. Similar way, I can rearrange all four inequalities where now E is my dependable variable and PE or the pre-stress or the moment can be the independent variable. So when you vary the moment, when you vary the P or when you vary the location, the moment will change and you can get what are the maximum and minimum values of E. So the purpose of doing this is, I mean, these A, B, C, D inequalities can be checked throughout the beam. So A and B will be the lower limits and C and D will be the upper limits of the eccentricity. So that means your tendon should lie within this dash region. So what we do initially, we design the beam at the midspan and select a suitable eccentricity. So therefore the moment will be the midspan moment. So if you substitute the end moments, then you can see what are the limits at the two ends as well. So then you can connect this profile and your tendon, if these inequalities are to be satisfied, your pre-stress force should be applied within this zone. So that means if you want to apply a straight tendon like this, it should be within this zone like that. So at the at the center or that midspan as well as at the two ends, the tendons lies within this permissible tendon zone. Otherwise, let's say by any chance this upper limit is like this, then you cannot provide a straight tendon because there will be, the inequalities will not be satisfied. So the next option is to go for a curved tendon profile like this. Right? So the tendons may not be any more straight, it will be a curved tendon. And again, this has to be determined only after you select a particular pre-stress. If you want a straight tendon, you can revisit and change the P value or the eccentricity value at the midspan and see whether it is changes or not. And that is why in pre-tensioning and post-tensioning, in certain cases we can insert straight tendons, and in certain cases we have to go for curved tendons like this because of the tendon zone. Right. And once we check the tendon zone, we have to check for the deflection. So deflection is checked at 3 stages. So first we should check the upward deflection at transfer there because it will be subjected to upward camber, and downward deflection under dead load needs to be checked right after you place the beam and place the finishes, and the long-term deflection can be checked when you apply the load and when the pre-stress losses has occurred fully. So all these 3 stages we have to manually calculate, or either analyze it to manually calculate and find the deflection and check it, because as I mentioned, there cannot be, I mean, we cannot define a span or effective depth ratio like the reinforced concrete, because this upward deflection will depend on the pre-stress that you apply. So, I mean, how to calculate the upward deflection? This is a simplification of your deflection formula. If you have a straight tendon profile, if the eccentricity is E, upward deflection Y due to this pre-stress force will be force multiplied by eccentricity times the span squared 8 over EI, where EI is the flexural rigidity. And at transfer, you can consider the elastic modulus as it is, representing the grade of concrete. So, I mean, the key thing to notice here is because the tendon is below the neutral axis, your deflection will be negative. I mean, downward deflection is considered positive. So, initially, we'll have a negative deflection. Then when you apply, I mean, so this is when the tendon profile is parabolic. And when you apply the loading, the deflection will be downwards like this. And if it is a uniformly distributed load like this, you know the deflection is deflection at the midspan is 5 over 384 times. Sorry, my writing is not that good. WL to the power 4 EI. Right. So you can find the downward deflection due to the applied load, find the upward camber due to the initial pre-stress, and when you add these positive and negative values, you will get the resultant deflection. Either it can be upward or downwards at the initial stage. And if the tendon profile is parabolic like this, actually this should start from here, the central part. So this due to this parabolic profile of the tendon, the deflection may again vary, but we can approximate that using this equivalent load method. And if you take this, first you can, using the pre-stress force and the eccentricity at the midspan, we can take an equivalent load as W eta, W is 8P over eccentricity at the midspan divided by L square, and substituting that to the 5 over 384, that T equation, you will get the midspan upward deflection due to this parabolic variation like this. P is the pre-stress force, E is the eccentricity at the midspan, and L and EI. So this is the parabolic due to the parabolic pre-stress loading, upward deflection in a simply supported beam. So then this will be again a negative value. Due to the loading, you will have positive value. So you can incorporate these two things and find the actual deflection. And the actual deflection should be less than L over 250 for the quasi-permanent case. Right? So this is the limit. deflection, calculated deflection should be less than this value, span over 250. That is the limit of deflection. And one more thing to notice is that the E value that we are, if you are calculating the instantaneous deflection at the initial stage, E value as it is can be taken. And if you are calculating the long-term deflection, the elastic modulus will change because of the creep. Creep means the deflection due to the long-term loading. Even if the load is constant, normally instantaneously due to the load at time t0 you will have some deflection. But due to the creep effect, even the load is constant, your deflection will increase. Right? So therefore, to account for that creep, Young's modulus is altered using this creep coefficient. So Young's modulus is actually reduced. This creep coefficient is greater than 1. So if this is the Young's modulus at the initial stage, the long-term Young's modulus is less than that. Right? Young's modulus F means due to the creep, it becomes more flexible. So when you subject this to the long-term deflection, you will get the deformation accounting for the creep deformation as well. Because when you decrease E value, Y will increase. And that is the deflection calculation. And I'm reaching the final stage of the presentation. All these are serviceability limit state check. Finally, let's see how to find the ultimate limit state. So at the serviceability limit state, it is true that this is behaving as a pre-stress member, which is pre-stress is under compression. So concrete is under compression, uncracked section. And this is where we do the initial design and the pre-stress design. But when it is failing, anyway, it will not fail if it is fully subjected to compression. Eventually, the bottom part will be subjected to tension and the bottom concrete will be cracked. And now the tensile stress will be carried by the reinforcement, just like the reinforced concrete beam, and the top part will be in compression. So at the ultimate limit stage, this is the condition. So there, what we look at is, just like the reinforced concrete, we look at the stress conditions. So at the ultimate limit state, it will have a triangular stress distribution due to the bending. Reinforcement will carry the tension. Top part will be in compression. However, initially, due to the applied stress, the reinforcement will be subjected to initial pre-stress strain. So apart from the bending strain, the deformation due to the bending, you will have to add the initial strain due to pre-stress as well. So that is the only difference. Once you add the two strains, you will get the total strain in the steel as well as total strain in the concrete. Then finally, what you have to consider is this one. The balance between the compression and the tension when it is subjected to flexural failure. So in flexural failure, what will happen is above the neutral axis, the top part will be subjected to compression and the ultimate strain in concrete is 0.0035. So that means if you know the depth to the neutral axis, you can estimate this angle using this is 0.0035 and this is tan theta can be found. When you find that, you can find the corresponding strain due to bending in the steel from this triangle, and that strain should be added with the strain generated from the initial pre-stress. Then finally, if you know the strain multiplied by stress will give you the force in the steel. And here the concrete in failure is assumed to behave like a rectangular stress block, where if this is the neutral axis, it is 0.8 times the neutral axis and the resultant compression is acting at 0.4 times x. distance, half of this. And if you know the grade of concrete, you can find the failure stress of concrete. So failure stress multiplied by this distance, you can get the, sorry, you know the area, the distance multiplied by the width of the beam. So this area multiplied by this distance, you can find the compressive force in concrete. If you know the strain in steel, you can find the force in steel. So if this compression and tension is matching with each other, that will give you the stress condition at the ultimate limit state. So the key design aspect to remember in the ultimate limit state is it is behaving as a normal reinforced concrete member with a triangular stress distribution, sorry, strain distribution. And the only thing is we don't know this x, the depth to neutral axis. So we may select a trial value for x and apply the strain distribution and find out strain in steel and strain in concrete, and then this resultant compression and resultant tension. So eventually, if you select the correct x value, this compression and tension will balance out each other. And then when they are balancing out, the moment carried out by that particular section is this force multiplied by this lever arm Z. So the ultimate moment carrying capacity is this force multiplied by the lever arm Z. So it's a matter of finding the correct x, depth to the neutral axis, and finding this f. And once you find this f, using the stress block, you can find the z as well. Then you can calculate what is the ultimate moment capacity of the section. So it's a trial and error method because we don't know this x value, right? So I am sure that, I mean, you may not fully understand it right now, but I mean, as I mentioned, now all these calculations, checks and everything cannot be done within short period of time. But the purpose of doing this is to arouse your understanding of the concept rather than the calculation. So if you understand the concept, doing the calculation will not be difficult because everything depends on the stress variation of a pre-stressed concrete member. And if you understand that concept, I mean, design calculation may not be a difficult task. So I suppose that with this understanding of basic knowledge on this pre-stressed concrete, just see how you can apply this into a calculation. There are plenty of resources. I will mention some as well. We can share that with you later. So those design calculations will be there, and you can understand those calculations and you can do it yourselves if you understand this concept. So with that, I will finish it here. And before that, if you have a couple of questions on what we have discussed, I can take some time to answer them.
Excuse me, sir.
Yeah.
I have a question regarding this. Can we use this precast concrete for seismic design? For earthquake design in Sri Lanka. Normally, we are not facing major earthquake, but maybe minor earthquake can be faced in future. Can we use this?
Of course you can. I mean, but as I mentioned, we can do certain seismic design detailing and checks whether these are going to fail during dynamic loads or not. Anyway, these have superior load carrying capacity than the normal reinforced concrete. But the only disadvantage in terms of the earthquake design, because of the stored energy in this one, the example, the bicycle spoke. So if it fails, suddenly this pre-stressing energy can release suddenly, and the failure sometimes can be catastrophic if it fails suddenly. So that is the only drawback. But other than that, I mean, of course, once you design it correctly, it can resist the seismic loads as well.
So what about the pre-stress losses? If not fail after this dynamic load, what about this pre-stress loss? Will it reduce or will it
Yeah,
same?
I mean, it will reduce because now the pre-stress force is what you call locked by these, if it is a post end member locked by these two anchor blocks. And during an earthquake, what could happen is these anchor blocks of the pre-stress can be lost due to the friction losses and the dynamic force of the effect. So in such cases, I mean, if it is unbonded, we can assess the situation and I mean, remove the cables and apply or we can jack it again and increase the pre-stress again to compensate for this lost, right? That is one way. And if it is actually bonded pre-stress element, I don't think there will be a significant loss of pre-stress due to the seismic load.
Thank you, sir.
Dear sir,
Yeah.
so I have one question to ask. When we learn about pre-stressed concrete, there are different design philosophies. We heard about some French school principle and the American principle and the German principle. Could you sir explain about what is the difference in these three philosophies?
Well, I mean, there will be certain methods that you arrive on the final solution, but the concept of pre-stressing will be the same, either it is done in US, UK, or Germany. I mean, basically, at the serviceability limit state, checking the stress conditions and making sure that they do not exceed the stress limit of concrete. That is the basic concept of pre-stress design. And how you do that can be different in different countries. I'm not aware of this German method as such, but the USA and the UK method and other maybe Indian method. There is, I mean, different charts and the equations that are used to predict the pre-stress losses and maybe the ultimate limit state capacity can be different, but the principle is the same.
Okay, thank you, sir.
So what are the concern need for the maintenance? I mean, it's a long-term maintenance for the normal RC structure and the pre-stress. So any additional concern about the pre-stress members compared with the normal RC or steel member for the long term?
I mean, long term anyway, both RC and pre-stress member, it can be subjected to corrosion, especially the pre-stress tendon if it is an unbonded section. Apart from that, the pre-stress losses, I mean, if you calculate it properly at the initial design state itself, so we can apply a pre-stress anticipating that after a certain period of time, this will be the loss of pre-stress in this particular member. If not, actually, what we can do is, for like post-tensioning members, we can reapply the pre-stress after a certain period of time. So those are I think, the long-term maintenance issues that I can think of.
Okay, if need to do the design, that time how to consider the crack. Means any concern about the crack control for the pre-stress? If for the bridge structure, most of the time we consider for the crack for the corrosion, those things for the normal RC beam. Something is compared with the pedestrian bridge, most probably be used for the RC beam. So it's a high, it's a vehicle, it's a road bridge is used as a post tensor. So that time need to consider any crack control means for the design need to consider the crack means
Crack
allowable.
control in the serviceability limit stage, you're asking?
Yes. Means
Um,
allowable crack force maybe is a 0.01 millimeter or something. Those things need to consider or only for this ultimate and serviceable design only is enough for that.
I mean, serviceability design, if we are going for class 1 sections as British code. Now there we can make, I mean, when you are design taking those inequalities, I mean, if we really want to prevent any cracks completely, what we can do is in the design stage, we can make sure that, I mean, tension or FA min T, minimum tensile stress of concrete is taken as 0. That means we are making sure that during the transfer stage and the service stage, we are making sure the cross section is completely under compression. So that way we can reduce the amount of cracks that can be anticipated, especially like structures like water retaining structures, we can do this.
Yes, so
Yeah.
like that is how to consider the bridge structure also. Need to consider for that
Yeah, bridge
design
also, I
also.
mean, we can consider different stages. I mean, for example, when you place the bridge beam before the deck, you can consider the stress state. And after placing the deck, you can consider the state of stress. And while it is subjected to loading, you can consider the stage of stress. At each of these stages, if you can prevent any cross section that is subjected to, I mean, prevent the cross section from being subjected to tension, you can prevent this cracking due to tension. But however, I mean, serviceability cracking is not only due to tension, because you can have like shrinkage cracks. I mean, if the curing is not done properly, then it can crack as well. So those workmanship aspects need to be looked after separately in terms of the quality. Whereas in design stage, what you can do is you can, at considering different stages, you can design it so that it will not subjected to tension.
So, what about the fire safety students' responsibility?
Sorry, I didn't hear your question.
So, what about fire safety students' responsibility?
Again, couldn't hear properly. Can you please ask in the chat or something? Yeah.
So, sir, again, so there is a no limitation for the crack. So only we have to consider that when the design the structure is always is a compression. That is enough, right?
No, I mean, I didn't get you right before. I mean, there is of course a limitation for crack. I mean, the structural crack. I mean, you have to limit the cracking to 0.3 millimeters. But I mean, we consider that aspect as a cracked section for concrete. I mean, normal reinforced concrete, because anyway it will be subjected to cracking.
Yes.
The normal reinforced concrete one. So we have to limit that to less than 0.3 millimeters. But in
0.3.
prestressed concrete, I mean, uh, evidently it is controlled because of this. I mean, we design it considering the serviceability limit stress, so therefore it is covered, right?
Sir, what about the fire resistance of this pre-stressed concrete compared to RCC? When we design RCC, we have to see cover for fire resistance. What about this
I mean, the
pre-stress?
same principles apply whether it is a pre-stress or a RC member. I mean, the most riskiest element is the steel. Um, But now compared to reinforced concrete, if the steel in the pre-stressed concrete get in initially, because anyway it is in high stress condition, the stress degradation can be what you call accelerated compared to the reinforced concrete. So, but the design principle is the same. I mean, we make sure that we have providing enough cover and enough section sizes so that the temperature will not penetrate up to the steel reinforcing levels. So that, I mean, they are kept below the critical temperature of the steel without reducing any strength. And also one aspect I can think is the bonding. I mean, because bonding is very important in pre-stress members, pre-tension members, if the temperature reaches the interface between the steel and the concrete, that bond can degrade significantly and pre-stress can lose in case of fire. So that is another danger. Right, okay, I think that's it.
Thank you very much, Dr. Veera Singha, for that very educational and insightful presentation and for taking the time to answer all of our questions. Now, on behalf of SLAICE, we would like to take a moment to express our heartfelt gratitude to Dr. Pasindu Veera Singha for delivering such an engaging and informative presentation by presenting a token of appreciation.
Thank you very much for the organizers as well, organizing this and inviting me. And I hope that the participants gain something out of this. Like I mentioned, I mean, it is not the full picture, but at least the introduction to the pre-stress concrete design.
Thank you very much once again, sir. Next, we are honored to be joined by the country representative, Dr. Kamal Laksiri. Dr. Kamal Laksiri is a distinguished civil engineer who graduated from University of Morocco in 1987. He later pursued his master's degree in hydropower engineering at the Norwegian University of Science and Technology in 1999. Then he completed his PhD in geotechnical engineering at Sal University in Japan. Throughout his professional career, he has contributed to several major hydropower projects in Sri Lanka. He worked on Samanalavawa hydropower project from 1992 to 1997 and later served as senior engineer for the Kukuleganga hydropower project from 1999 to 2004. He also served as a project director of the Broadland hydropower project from 2008 to 2024 and currently serves as a project director of the Morogolla hydropower project. And during his professional journey, he has held several prestigious positions, including serving as the president of the Institution of Engineers Sri Lanka. At present, he serves as the country representative of the Institution of Civil Engineers and also as the governor of Region 10 of the American Society of Civil Engineers. May I now warmly invite Dr. Kamal Laksiri to address the gathering. Sir, over to you.
Yeah, thank you very much for the kind introduction. Can you hear me, please?
Yes, sir.
Okay, good. Thank you very much. And also, extremely sorry about my late attendance. I was scheduled to join early, but today we had a field visit arranged to visit Sobadani power plant, and we were planning to return early, but it took time and I returned late. First of all, let me thank the Dr. Pasindu for the interesting lecture. Dr. Pasindu Virasinghe, senior lecturer from University of Moratuwa, for conducting the very informative and interesting presentation for our young members. I was also following it, and so it's very useful, and I think the members got a lot of knowledge from this lecture. Before that, I also want to make a small correction. Actually, my introduction, maybe my mistake. I could not update your president about my current status. I retired recently, so I'm not no more holding the position of project director Morogolla. So I last worked there. Maybe in the future you can correct it. Then yes, now today I think it's a very good example. This lecture, the CPD activity you organized, and how you got added your additional knowledge or new knowledge as practicing as young engineers. Now, engineering, our profession, is of course true for the other professions as well, but still in engineering, the knowledge, new knowledge is required necessarily. But the technology is changing very fast. As engineers, if we are to be successful, we need to be updated with the knowledge. So one of the main targets or the tasks of the professional bodies is to help members in getting new knowledge. So that's why we are, in my definition, I always call the professional bodies as our lifelong partner in professional development. So as engineers, especially when you're as young engineers, young engineering students, you in the university, we all get the basic knowledge in engineering. But then once we come back to practice, you need to continue your education. That's why we call programs called CPDs, continuous professional development. So those programs are conducted by the organization, the professional bodies only. So when you are attached to a professional body, you get this opportunity to continuously gain new knowledge and also network with your peers, not only in this country, whole in globe. Now in some events, maybe you have noted that we conduct these programs along with our regional members. So there's a good opportunity for you to network and get contact connections with the members or the specialized people in the subject areas in the different parts of the world. So there are many opportunities. So as young engineers, I request you all to continue with your professional bodies. And as Sri Lankans, in first place, we need to get our local body membership. That is the Institution of Engineers Sri Lanka. Then we have the various professional bodies, again leading well-recognized institute is the ICE, Institution of Civil Engineers, UK. It is one of the oldest professional bodies in the world, and also well recognized. That membership is recognized internationally, And also you can find, and in Sri Lanka, we have a large number of members from since a long time. And I think you have met some of us, very senior members holding this membership since a long time. So you all have this good opportunity to join as students and then continue in your membership ladder. Then you can be once you complete your studies, be an associate member, then the full member, then the highest level of fellow member. About these memberships and how to get the member, already you have joined, and so it's for you to, it's only continuing in the ladder only. So again, how to become a professionally qualified engineer, all that details we are planning to conduct a program soon. I think April, we have decided that we will inform you the date. It will be in April, along with the participants from the headquarters, UK. So there also you can learn more about your career development in ICE. So I am happy that actually IC Sri Lanka section, we have a large number of students. And in fact, we are one of the major student sections in IC, within ICE, because we have students covering from north to south, all the universities, and very active, conducting many programs. I think before this event, last event was a field visit. I think I also joined with you to the Central Expressway, and also we have arranged another visit to water treatment plant soon. So there are many, and I request all of you to be actively engaged in this events so that you get additional knowledge and you can be competitive and up to date with the new knowledge. So but there's a, when you start to practice, actually, if you are not thorough with your subject, and if you have not developed your competencies, you can't survive. And I heard, we have observed that in the recent past, there was a general trend in civil engineering. There's no lack of interest in civil engineering. I think mainly because of the boom in the IT industry, and also with the opportunities in the industry. But it's not a fact to be worried, in my opinion, because this is changing. Even I remember when we were in the final year, we were also highly worrying about whether we can find a job, but it was not the case. And also those days I remember we were fascinated by the then ongoing major projects like Mahaveli. So because of that, a lot of people, us, selected civil engineering as the first choice. So it's like that. So time to time it changes. So never worry about it, this situation. Currently, I heard in all the universities, the last choice is civil engineering. But you know, it's not a reason to be worried, because there's a big demand, because infrastructure development, there's a place for every day. I mean, this is increasing. Time to time, there are some issues, but still it is temporary. So it changes every time. So what we need is to get ready with the knowledge, and also not to look for only for government jobs. You can be an entrepreneur. There are many other opportunities. So that has to come from us. Actually, we have to be competitive, and then ready with the new knowledge, and we have to develop our soft skills, and to actively work. All those can be developed by joining with the professional bodies, and then at the earliest to get your professional qualifications and become a professionally qualified engineer. So all that can be done. So all depends on you, actually. You need to work with others, and there's no reason just to say, just keep on worrying that there's no possibility, everyone is going for IT. Yes, you can develop your IT skills and using the particular discipline you are engaged in. So there are many. So it's all dependent on your commitment. So these are some facts I wanted to discuss with you, and in the next event we will discuss further, and you can engage in with the chapter, your student chapter, I think here not only Moratu, there are many from other universities as well. So be with the SLAES, and then you can be a member in our main committee. And so actively join in the various activities, and also you can suggest and organize events, and that way you can be a competent engineer in the future. So if there are any issues, I would like to answer you, and in the next event, we will give you full details about the IC membership and about the requirements for the professional review, etc. I think we will announce the date later. Then we can meet. Ashin, are you there? So if there are any questions you have or anything else to discuss, I can.
Yes, sir. How to renew the existing graduate membership accounts?
All is online, actually. It's very easy. Now, as soon as you complete your, those who complete, now I think most of you are here in the final year and third year, I guess, right?
Yes, sir.
Yeah. So as soon as you complete your degree and with your, yeah, you can, you don't need to wait till the convocation. Once you get your transcripts, you can submit online, and then you can transfer your membership from student to graduate membership.
Okay.
If you face any difficulty, you can contact us and we can help. And if they ask for references, that we can give. So I request you to, because we have seen students in the recent past, actually, that is mainly because of this crisis situation we had in the country, and employment difficulties, and also because of migration, lots of young engineers were not continuing in IS, both in ISL, ASC, IC. We saw that even there's a reduction in applications for the young members to the next level. So we saw that actually, but then we were conducting various programs to encourage, because you should, once you study in the university and complete your study, you should not leave it. I mean, the wealth of knowledge and very valuable qualification you have earned already, so that you should not waste. What you need to do is to improve it further. So not to be worried by the situation in the world or in the industry, but time to time it changes. But what we need to get ready with, and to get ready to face these changes, then you can be successful. So as soon as you complete your final exam, and once you get the result, the transcript, you can immediately submit to the headquarters online, all online actually. And if they require any certification, that we can provide from our end, with the senior members, and then you can transfer to the membership. So one day you all should come to these places, the country representative. Now I joined IC as a young student member like you in 1988. So those days actually we had to pay 10 or 15 pounds, but with great difficulty somehow we managed and continued it. So because of the interest I had. So I think you should continue, and also you can see, if you go to our IC website and the newsletter, wealth of information, very useful papers, lots of, and also you can select the particular area, maybe geotechnical, structural, transportation. So depending on your choice of field, subdiscipline, there are different sections with publications. And in the case of US institute, there are separate institutes also. So once you get the membership there, you automatically get your preferred institute. So they are actually, you will find lots of wealth of information that will be very helpful. Even when we practice as engineers, even our seniority level, we find as seniors, we find every day a new problem. And what we have learned is not enough. We need to refer to various books or the papers. It happens. So if you are ready and if we have established the link with you, you can be ahead of your colleagues. So please take that into note, and we are there as seniors. We will be there to help you. I think we can if invite Dr. Pasindi also to join us. If, I haven't met him before. If whether he's a member or not, I'm not sure. So I think I want to thank those who organized this event today. But this actually this is not my area of specialization, but I was following it. Very interesting. You know, this is how after you for you actually it's just very recently you must have studied this in your university studies, but lately after you passed out, when you listen to this type of lecture, it will be very helpful. So you can refresh your knowledge and also apply and see. Maybe you all heard there was a beam failure in the Central Expressway project. It happened in the Kadawathu section, Kadawathu Mirgam section. The contractor, there are various stories about it, but I think the wrong way the beams handled or placed or something like this. So when this type of problems, when you face, if you are a site engineer there, you need to analyze it and see, you know, this is very important. The contractor may come up with various excuses. I think it was a big problem. Maybe you have seen it in the news and heard in the newspapers. So then this type of knowledge, when you are ready with knowledge, it will be very helpful. That's why we need to know to keep our knowledge updated every day. Okay, any other things to discuss? So please tell your colleagues. You can ask your friends also to join if they have not joined you. And then all those who are already members should please remember to continue your membership. It will help you a lot. In the case of Sri Lanka, the membership fee is a problem for many members, even senior members also find that. But if you are in the government job, not only government, even private sector organizations, some organizations, if you request, they reimburse the membership. This is happening in many leading companies. The government, of course, there's a circular and your right to claim one local institute and foreign institute membership annually. So you can simply pay the membership and even associate membership and the full membership you can pay and request your particular organization you work. Then they reimburse you. Then this is not a big problem maintaining membership. Most of the private companies also they reimburse. So all depends on you when you perform well and when you request. In the case of private sector, there's no such regulation or rule. But in the case of government, universities, government sector organizations, there's a circular. You are entitled for reimbursement for one local institute membership fee and a foreign membership. Hope it's clear to you, and in the next event we will discuss with the membership department about various things. I remember last time there was another question about the IC library. If you go to ic.org website, there you can join, you can register in the my membership area, then you can access the IC library. And there's a question in the chat box. It's government sector does not support even CPD courses. Actually, what happened was, no, it's not true always, because whenever when there are CPD courses, recognized CPD courses conducted by the professional bodies or the various other recognized institutes, this circulated to the government, the organizations, and then they nominate some program. They ask the organizations to nominate members. Then generally it was happening, but maybe you are referring with the crisis situation. I remember we had to cut down many such expenses. Because of that only, the government, the sector does not support even CPD, because that situation arose. But now again it's changing, because we find in ISL, because there are so many CPD programs every month, there still we get nominations from government bodies when the particular organization find that this CPD is useful for their members, their engineers. They nominate people and they pay them money. It's happening actually. Even private companies do that. So there's a reduction, I agree, during crisis time, because the crisis time, the most of the organization, they to cut down their expenses. So they stop this type of programs. Even we gave concessional rate, that also we also had to from ISL, I remember we had to do some changes. And also if you look at IC membership, IC also conduct online programs. Of course, there are other programs for their members who can attend in person, but there are very good programs. One such international lecture is the Brunel lecture. So there are programs like that you can join online free of charge. And so in some cases, they issue CPD credits also, so that later you can use. Now, in some countries, you need to continue maintain certain number of CPDs. Now, it is there actually. If you once you become professionally qualified engineer, if you get the international professional engineer status, it's called international inch P-inch qualification, recognized in many countries. You need to maintain minimum 50 credits, CPD credits annually, either by participation. There are actually specified how to earn 50. It's not only by attending webinars, workshops. So there's a criteria defined by the institutes. It's internationally established criteria. So you need to maintain that 50 credits per year. Otherwise, you can't continue the membership. So when you have attended this type of program, you can record it, and then later you can claim that credits to show that you have covered 50, the annual requirement. If we use Europe, I think this is okay. This to the. So please feel free to ask any questions you have. Maybe some of you want to leave because it's a little late in the evening. And I request all of you to join in our next event we conduct with the headquarters. Ashin, we have not circulated the flyer yet, I think.
Actually, sir, next week we have a field visit program in
Yes,
Batale treatment plant, and then March 27 we have another CPD program in pilot testing and implementation.
okay.
And then March 28 we have a career fair program in online mode, and April 2nd we plan to conduct the ICE session about the career path of ICE after graduating the after complete our degrees, how to continue our ICE journey. Session will be organized in April 2nd. It is
Okay,
also a virtual platform.
Yes, yeah. Okay, any other things to discuss? And also, I want to request you all to decide your preferred area by now. I mean, whether to specialize in structural or the water or the transportation, and you select a field and work on that particular field only, because we see today our engineers, they just do, for example, the postgraduate studies, whatever the opportunity they get, they just follow it. Because in the government sector, if you have completed the master's degree, you get an allowance, 50%. It depends on the, I think, different organizations, about roughly about 15% of your salary as an allowance for your postgraduate qualification. So sometimes there was a trend in the recent past that most of the engineers were doing MBAs. There's no problem at all doing MBA by engineer, but MBA, but the topics were totally irrelevant to engineering. Because they were doing, that was the easiest way to get a master's qualification. So it was a problem actually. And I remember in some organizations started to decline that, or they not to recognize such as appropriate qualification for to grant that salary increment. So I think you should not do that. If you decide that, okay, I want to be a specialized in structural area, you should do your chart, your the CPD, everything in that particular area. From my experience, I can tell you, I had a great desire to specialize in hydropower sector. Somehow I developed it in my university time. So I was reading books, and in fact, I'm from Moratuwa. Actually, I studied in Moratuwa. We had this small library in the Moratuwa. So there I was reading relevant journals. Then that's how I tend to get the membership, also international membership, where I found these journals are published by the various international bodies. Then I got the opportunity to follow a master's degree in AIT, Thailand. You all know AIT, it's a famous place. But still, it was on some subject or something else in infrastructure development, or it's a common subject. I didn't like it. It was a full scholarship. One of my friends, through his professor, arranged it, but I declined that time. I wanted to do a degree, postgraduate program, but I didn't do it because I found no. If I do it, it will not help to my interested area. Somehow, after many years, only I got the opportunity to follow a master's degree in the subject area I wanted. So similarly, you should decide your specialized area and work on that line only. And then you can be a very competent engineer. And also when you are selecting jobs, yes. Now, when you select your first job, maybe we have no choices. So first thing, you need to somehow get an opportunity to continue, give a start. So you grab the first opportunity you get, and then from there, then you can sort out your financial situation, and then also you get opportunities to look at the industry, connect with the industry. Then from there you can select the path you want to go. That's how you should do, not just in ad hoc manner, whatever the opportunity you get, and you know that way you can't reach your goal. And also when we look at the areas now, everyone many wants to do specialize in structural, but also remember that there's a greater demand in the contract management. But today we engineers, it's nothing to do, nothing wrong with you, but when they come to senior engineers, now we find many interested in other areas. Our contract management side now invaded by other professions. In the case of internationally, it is by lawyers, and in the case of Sri Lanka, other categories, not the engineers. So this is also a problem. It is a subject of engineers. It can be civil, electrical, mechanical, but still it's only engineers can do in the project management, well in project management. So develop that area. If you are strong in that project management, learn contract law, contract management, various international practices. It's also very big prospectus in this discipline also, but we see there's a decline, maybe because of you are not aware about it. But still I request some of you think about it and develop your interest in that subject area as well. Anything else you want to ask me? Is it possible to reimburse member fees only applicable to engineers position, government, or any other related position like? No, it's only for engineers. Is that your question? You're asking whether non-technical officer or anybody, right? Question by
No, sir. I'm asking if anyone having the position, unless engineers like technical officers related.
no. But the other thing, technical officer cannot get a professional body membership, right? Because
Yes.
they are not. If you look at a technician level, now in the case of IC, we have this lower grades. In the case of local institute, that is IS, also we have companion and other grades, but those are not eligible. They cannot. It's only for the engineers we have.
Okay, sir. Thank you.
Sir, good evening, sir.
Yeah, good evening. Yes.
I am as a chartered engineer, UK, instructee.
Okay.
What are the way to convert the chartered membership to the IC? Any way to do the chartered membership, or how to do the procedure? Can you explain, sir?
Yeah. We have got a very valuable qualification. I think were you in UK or you studied here?
I am here as a working and UK chartered engineers already. So also as a member of IC also, but as
Okay.
I haven't continued because it's an annual fee. So
So you could reinstate it. No, you said you got the iStructy, right? Membership.
yes, I have.
Yeah, it's a very valuable qualification, and the other is very difficult because we know lots of Sri Lankans who applied from here could not get it. I know some associate members. So so now so you were the member of iStructy, right? Now you want to convert it to ICE, right?
This IC, because I haven't followed the IC membership for the annual fee issue, so I stop it with the
No,
iStructy.
okay.
So
So were you a student or associate in ICE before?
IC is graduate. First year is a free. That time is a long. I think it's a 3 4 years ago. So that time I just apply as a member. Then after that ask me to the payment for annual fee. So just drop it.
But then you paid for the iStructy.
Yes. I'm still is a member iStructy charter.
Hmm. So then if you get it, you have to pay for both. Yeah.
No, I
But
just asking sir, any offer for a discount for this boys both
no, yeah,
institution.
no discount wise, no actually, but those are two different institute.
Yes.
Only thing when you apply here, they will exempt you from but still since you are graduate, now you want to be a full member, right?
Yes.
So if you write to them, right, they will exempt you from other requirements since you have already got the iStructy, right? But still the assessment fee and the annual membership you have to pay separately. But my recommendation for you, where are you? Are you working in the industry or the university or where are you?
No, I'm is working in industry.
Industry, okay. So you are practicing in structural engineering?
Yes. Structural engineer.
Mm-hmm. So in that case, why don't you continue with I mean, if you can afford, there's no issue at all. So you can maintain both memberships, or you want to drop iStructy and jump into IC only, or what? But iStructy is a very valuable qualification. Even within Sri Lanka, I don't think we can find 10 members with the full membership in iStructy. So maintain that, my recommendation.
Yes, sir. So I maintain this extract tea, but
Yeah.
ask sir I like to join this IC also.
So, yeah, you
So
are most
now
welcome. Yeah.
because I haven't continued due to this fee subscription fee.
No,
So
you can
it's
reinstate. You can reinstate. So they will not charge for the past years. So please refer to me also and apply them again, right?
mm,
Giving you our old membership number.
mm,
Maybe you can
yes,
record. You must be having all those. So with that, you refer that and request for the reinstatement of your membership, right? Then they will put you in the appropriate place, and then there you can mention about your uh, iStructy membership, and also that means you have registered with the Engineering Council UK as well, right?
yes.
Okay, so then you can continue easily
Mm.
and get it reinstated, and we would like to be with us, and yeah, you can join these committees. Yes.
Yes, I think.
Okay, yeah, okay. Then there's another question. I have completed in the ESTTI, and after that I have completed a top of degree at University of Wellington. Scenic. Okay, what are the paths that we were having going? So at present, what are you doing? You're still this last question posted by. Can you elaborate further? Can this last question, I can't read the full thing. Can you ask him to call or? Ashing, can you hear me?
Yes, sir.
Yeah, this is a question. I can't see the full thing. Something happening. It's about this scenic. If he's there, he can explain it further.
If you have a problem, you can turn on the mic and directly ask from the.
There's one more question from Tutua. Female undergraduate. I'm interested in project manager from what I see through my internship period. There's a lot of barricades. No, it's not a barrier. They being a female member. Can you explain me? Hello. PD Hattutua. Lot of barricades for female members. Ashin, is she there? Hattutua?
Hello. Am I
Yeah. Can you elaborate it? Yes.
and my certificate at construction site. And through my skills there, I felt like because like we have both the sites, I was like at some positions there, I didn't have the in terms of
Your
safety.
voice is not clear to me. Something wrong with the connection? Can you repeat it? I could not hear anything.
Am I?
Hello.
Yes, go ahead.
Yeah. So during my internship period, like
Okay.
I felt like as because like I was interested in project management and
Yeah.
but I understand that to reach that position you have to start as a site engineer and then move upwards and but I feel like because we can sometimes like being the sites that I was in and I was like asked to leave early and I understand there are safety issues for that as well and uh, and I feel like because of that, like to reach that position, it like not being able to be there will sort of uh, like push us backwards in terms of going upwards in the ladder. That's the sort of uh, like picture I got through my experience.
Yeah. Maybe you got that experience in that particular place, but that's not the case always, right? Maybe because of the setup there, but in my career, I have come across many and who are doing very well. It doesn't matter whether you're a male or female. It's a good opportunity for a female because when you become a specialized in contract contract management, you don't to be at site full time. I mean, in the supervision work, not like in supervision work. So it's mainly office work, and there's no issue at all. Actually, maybe you have got this experience in that particular location where you underwent your internship training. Then maybe it may be the situation not only for project management. If you are specialized, want to specialize in some other area, also it may be the same because of the situation. I guess the situation prevailed there, but it's not true. Never give up. If you are interested, industry, there are many paths, many possibilities. There's no hindrance just because of a female member. No, it's not true. So we have seen many of our female colleagues worked equally well with all these areas. It's not a big issue.
Thank you, sir.
The contract management, what you need to do is, now in the university you get little time to study, but read and learn from other courses, others, various CPD programs. You develop that skill yourself. Actually, in the case of Moratoa, I happened to attend in a meeting in the industry board of your university, Moratoa, where I suggested to the staff members to make it compulsory subject or elective or whatever you call in at least in the final year. So because as engineers you need to develop this skill and get ready with sound knowledge in contract management when you pass out. Otherwise there are various other threats from other professions. They're trying to invade it, but because it's ideally in the past, in major projects we had the position called contract engineer, which is a very important position. Normally second to the leader, the team leader, or the in charge in the project, because he's the one who governs, who decides many things, and we advise the team leader. So, but unfortunately now it's not happening in the same way we practiced in the past. So, but it's time to revive it again. So that's why I'm requesting always young engineers to develop it and one day be a good, competent contract engineer. That's one aspect only. Of course, there are structural, water, depending on your interest. But think about this area as well. I could not reply to this issue on this CNEC again like this now. Whether it's
hello, sir.
Yeah. Yes.
Hello.
Go ahead. Yeah. Go ahead, please.
Yeah, sir. Yeah, sir. I'm a diplomate. I have completed it in TTI Patna.
Okay.
Then I have done a top-up degree in at CNEC that is based on UK top-up degree. So I asked that what are the opportunities that we have from that degree.
Okay, good question. Now it's like this actually. What's your good name? Is it
Uday.
Uday. It's like this. Now even I see when you apply for the first time, the first thing they do is they check your educational qualification, whether you're a student member or even the senior person. First time if he's tried to join, I see the first thing they do is the assessment of our educational qualification. Now, I think in your case, now you all are very lucky, those who follow recognized the degree program. Now in Sri Lanka, in the Moratoa, there are many degree courses they recognize. In our time, actually, the local universities were not recognized. You need a master's degree on top of your basic degree. But now the situation is different. But again, there are certain they're qualified, or the what you call the accredited programs or recognized programs, and when you apply, they will check your university, the course you have followed, because we have to submit all the details. So, but unfortunately now there are several top-up programs. Automatically you will not get the recognition. So you need to be careful. Actually, it's a very sad situation now, because it's not your fault, of course. There are various institutes, it's kind of cheating. Actually, they give various false information and conduct programs and earn money, and people go and follow these programs. The organization do not recognize, right? The institute will not recognize it as a accepted qualification for a particular membership. In your case, I do not know, I can't say at once this qualification, the top-up course you have followed falls under the accepted category. So then there are paths like technician engineer, incorporated engineer, various other programs. But if you are intending to be a qualified professional engineer, you should not be worried. What you need is to follow a proper course, right? There are many. Now, if you are living here, now since you have done some work, I can recommend, okay, easiest way to follow join the Open University. There, while working, you can do it. You can join laterally. So depending on the level you have, education you have earned already, you can decide to which level you can join, right? And in addition to that, we had other programs like CPDs, but now they are suspended, I think. So without following that, there are various categories. In the case of ICE, local institute, say, you all know the Washington Accord accreditation is the accreditation degree only we recognize in Sri Lanka, because since 2014, since we became a member of the Washington Accord. So my recommendation for you to just doing a top-up will not help, but it should be a proper program. So if you are in Sri Lanka, you check with Open University. And earlier we had ISL Part 1, Part 2, London Part 1, Part 2. So there they will assess and exempt you from some parts. You don't need to do a whole thing, because now in your case, if you happen to follow a degree again somewhere, I mean, it takes a lot of effort, money, time. So try that way. Otherwise, and also I want to give the message, whenever if you are selecting courses, be very careful, even postgraduate courses. Because today it has become a business, and if you look at some weekend papers, many programs, but you have to be very careful. Check whether it's if it's a Sri Lankan one, whether it's a UGC recognized, ISL recognized program. If it's an international one, also they use the foreign university names, but sometimes it's not up to that particular university standard level. We have found many such cases. So you need to be very careful with such arrangements. I think we...
Okay, sir. Thank you.
Okay. I think we didn't miss anything in the chat box. Ashane?
I think no, sir. We answer for all the questions.
If not, we can then wind up the program, and again we can have, I mean, we'd be happy to join and assist you. Anyway, we will have our next big event. There's one more.
In April 2nd, you will get a thorough understanding about ICE journey, how we apply graduate membership, how we go to the incorporated engineer level, and the chartered membership qualification, how we obtain these professional qualifications, you will get a very broad understanding with this session, and our senior professionals in the ICE will come to that session and you can clarify all these problems from them.
And one last question, I think just arrived from Kavishanath. I think you are referring to the ISL qualification. Is that correct? Ravishanath?
Oh, yes, sir.
Yeah, basically, yeah. Now, local charter, the 48 months of training, professional experience. Then out of that, you need to get because in Sri Lankan situation, when you say chartered engineer, you need to be equipped with both design and construction. So you need to have 12 months of design experience and construction experience. So that can be, that site experience is good enough wherever you, maybe road project, water project, the power project, building project, anywhere under a supervision of chartered engineers. Once you get it, you get the charter status. After that, you can continue in project management. I mean, it doesn't mean that you need to follow project management before the charter. There's no such. I mean, charter, it is common. What is necessary is to get the proper training, design office experience, and construction experience. After that, you decide, okay, I want to specialize in design. You can then be a good design engineer, only involving in the designs, specializing in designs, or construction expert. I hope that's the answer for your question.
Okay, sir. Thank you. Thanks, sir.
Yeah. Actually, if there are no questions, we can wind up by this point.
Yes, sir.
I am okay. I mean, if you all want to discuss anything. Sorry, my late arrival because of various other assignments. Actually, we were with lots of young members today on a visit to the Sobadano power plant. I had promised to join then. We were planning to come by 3:30, but somehow the site visit, takes time and dragged longer. Okay, then shall we wind up?
Sir, yes, we can wind up. There's a little part left. More. Thank you very much, Dr. Laxity, for your inspiring and encouraging words. And now, to deliver the vote of thanks, may I kindly invite the Secretary of SLAICE Student Chapter, Tinu Ratnayaka. Over to you.
Can you hear me?
Yes, we can hear you. Yes.
Okay. Thank you. Good evening, everyone. As we conclude our insightful CPD session, it is my distinct honor and privilege to prepare the vote of thanks on behalf of the Students Chapter of the Sri Lankan Association of Institute of Civil Engineers. First and foremost, I would like to Thank our resource person today, Dr. Pasindu Veerasinghe, Senior Lecturer of University of Moratuwa. Sir, thank you for taking the time out of your busy schedule to share your immense expertise with us today. Your practical approach to introduction to prestressed concrete design has undoubtedly strengthened our technical foundation and inspired us to look at structural engineering with a more future-ready perspective. Next, I would like to thank Dr. Kamal Laksiri, country representative of ICE, for sharing some valuable insights about the importance of professional bodies and walking us through our professional journey ahead as future civil engineers. I would also like to extend our thanks to the SLICE committee and our student chapter members for their tireless efforts in coordinating this event. A special thank you for all the participants for your active engagement and the thought-provoking questions you have raised today. Your presence is what makes these CPD sessions a success. We hope this session has been a valuable addition to your engineering journey. Thank you once again and have a pleasant evening.